Um, you're going to notice that I'm going to start off today not by giving you an outline of what I'm going to talk about, but rather what are your learning objectives for what you should be able to do at the end of this time that I give this presentation. You know, I hope that you're going to do as I say and not just what I do, because you know, we can make critiques of ourselves even now. Sometimes done is better than perfect. I am actually very humbled approaching today's task. Many educators in the ACI community are well-seasoned, educational professionals with decades of experience, whereas I'm a transplanted industry professional, PE, with 12 years of design and DOT experience. You know, I was transplanted into the academic community about 6 years ago, and it was in a teaching priority institution. Okay, so I'm a duck out of water, but at the same time, that's what makes me really adaptable. In this paper, the authors envisioned an audience primarily intended for new faculty members and those that are also new to active learning. Okay, this is supposed to be a jump off point. We're going to do a brief overview of student-centered teaching methods, and there will be some framework and examples as well. So active learning, what are we talking about for active learning? Active learning requires that students engage with the material in real time, okay? That is different than passive. We'll get to that in a little bit. The reason we need to, I said, we also laid out a reason for why should we change some of our methods or consider changing some of our methods. Our first presentation talked a little bit about the education pedagogy research that's happened over the last decades. But also today, our engineering profession is rapidly changing. I see civil engineering positions being filled with non-civil engineering degrees, not even non-engineering degrees sometimes. Outsourcing is common. Often we look at maintenance rather than construction and original design. The technology is becoming very transformative. Our projects in the future are going to be radically different than the ones that I designed and I worked on. So the goal here is we need to produce engineers with the technical knowledge and the skill that we need for the, but we need to add up more. We need to add an extreme adaptability. We need engineers that self-teach and that are comfortable dealing with ambiguity. And notice I said comfortable, not can deal with it, but they're comfortable with it. That's going to happen more and more. So, you know, you're probably aware of the global reports about who is the engineer of 2050 or this one, which is the Global Engineer Survey results, you know, talking about what we need to do and prepare for. We have, the past thinking in the past, we've thought about methodical steps and how to produce an engineering product, and we've made incremental steps. But the reality is now we're going to start moving towards out-of-the-box thinking. Okay, cross-disciplinary projects, interdisciplinary, whatever the wording is you want to say, even post-disciplinary projects are the things that the engineers, the employers are calling for. So we need to rethink in some ways our educational systems and make sure that we're using the correct tool at the correct time to improve student learning. Okay, so this paper was meant to be a jump off point. It's not meant to be the sole source, but rather we wanted to give options for the new faculty member who is new to active learning, an opportunity to go in a couple different directions. So this is where I introduce just a bit of learning theory. Of course, we all focus on our students. You know, that's why we teach. That's what we do. But student-centered teaching is a phrase that is defined in this educational theory and learning theory as having, you know, being developed and designed as we're looking at the student's experience as they're learning and the experience of the course itself. It's not looking at the knowledge content. Regardless of how we talk about student-centered or not, the reality is much of our learning falls into these two categories, either active learning or passive learning, okay? And we know from the research and decades of research that the active learning is the way to go. And the reasons is because it creates in a student not just an ability to complete a task, but they make connections far beyond what we would make just practicing our standard textbook problems. The students are actively engaged during class time, right? And we in civil engineering are fortunate to have a large amount of hands-on work when it comes to, say, concrete or materials, but in some of our courses. But unfortunately, sometimes we don't pull that over into the lecture portion of our classes. We have in the past looked a lot at the passive learning styles and used that. It's easier for us as faculty members to prepare. It takes less time. We usually focus on transferring knowledge, the way things are, and the way you need to catch up and understand what you know, the method is and be able to complete the method to get the right answer. And students are listening, they're taking notes, but they are not engaged. So I wanted to give you a couple this paper presents a couple different pieces of information that could be helpful for you. First of all, as a faculty, to design the structure of your course and the scaffolding to go from one topic to another without it being a disjointed set of facts that's placed together randomly. We can look at, and it helps students to connect things and make connections themselves with these theoretical concepts that they maybe are seeing for the first time. A traditional way to look at concrete durability would be to look at the intersection for the Venn diagram here of like chemical reaction-based deterioration mechanisms, physical deterioration mechanisms, or a combination physiochemical. This is maybe a traditional way. So here's a couple more that we've seen or used. We can look, you could present it in terms of the age of the concrete, right? That we could look at these different factors, the plastic shrinkage, autonomous shrinkage, those happen within, you know, one day or one week, or those that take maybe a year. And why is that happening? And what is the mechanism for that? Or sometimes they're very slow to develop. So we can look into the decades. This one's my favorite, which is actually expanding the previous one onto the early stages of the question of time. It, you know, when we ask when does the concrete crack, if we place it in terms of the construction process itself and just follow the life of the concrete from beginning to end, starting with the raw materials, the mixing, the construction, and all the things that can go wrong in between. These are ways that the students can connect with why this is relevant and understanding some of the mechanisms and how long they take. time relevance for students, as far as decades, there, you know, is not particularly easy for them to grasp sometimes. So this is one way for them to start to touch that, understanding that maybe these students know the construction or they've even done it themselves. That can help create a personal connection to the material. We do double duty here, even learning about the construction process of concrete structures, not just the concrete and the durability issues, okay? And, you know, these decision-making processes in the real world. This paper, we knew that we couldn't and didn't want to even try to be the only you know, source for information, but we thought it would be good for the new faculty member if they had a source where they could look at different pedagogies for how to teach, and then also the topics. And we created a matrix here, and we're not trying to give examples for all of these different places, but you know, the ones in green are ones that we picked. And we have provided in the paper multiple examples for each of them. I'm going to talk about just a couple different, maybe 3 examples. One is a concrete selfie assignment. Then we're going to talk about a particle size distribution assignment, and then a metacognitive reflection. This is Jacob's selfie deterioration assignment, where in the first week of class or so, he asked the students to go out and, you know, take a picture of themselves with some sort of concrete deterioration. And then if you were to take that, and as you develop through the class, if it's a concrete materials class, understanding the deterioration, the students will start to recognize, especially if you have them continue to submit pictures of themselves and discuss what are these likely reactions or what's causing this, they tend to start making personal connections with when they understand and they identify it in the real world in their lives, right? So that's an interesting way to go about it. It's pretty easy for you as an instructor. I really appreciated Lisa's comment about using cooking to make metaphors. I do that as well. So I'm going to give you one, but not exactly the same. So generally, I would have a conversation about the 5 ingredients in cookies, or like bring Chips Ahoy cookies to school, to class, different kinds. And we would talk about standard mixes. Maybe that's the Chips Ahoy of regular cookies, or admixtures might make it Chips Ahoy chewy. Different aggregate gradations might be the chocolate chunk, right? These are some of those metaphors. Now, I then move on to say, okay, when we create cookies, often we do them for different purposes, or and you know, maybe it's a party, or maybe it's just an after school snack. And in the same way, our concrete has different applications. We can look at a binder system that's not concrete, but is actually compared to, in comparison to concrete, to look at asphalt and develop no-bake cookie recipe for this. I really give the students during this class time, it's an activity. You know, I had talked about particle size distribution and how it affects the mixture properties. We then move into this idea of how do you do no-bake cookies, and that here's maybe a standard recipe. Now you'll notice that not all the information is given here, right? And I don't let them see that either. I then present to them this challenge that they are now going to create a mixture that has a properties for a specific application. And they have these materials, and they can go figure out how to do that themselves. It's very ambiguous. Okay, the aggregate testing concepts and the sieve analysis has already been introduced in previous classes. But let's see. Oh, and then they're assigned in groups to work on developing a mixture that will perform for various applications. One of them is always just a highway. One of them is a parking lot. One of them, and they might be using pervious concrete. We had already talked about that. One may be a racetrack. That's very popular. And then they want a smooth surface, right? And another is a crack sealant, right? At any rate, we can do this for concrete as well. What's happening here is we're developing they have to develop a strategy. They have to develop a recipe. They have to develop a procedure. How are they going to actually get to the end? And they have to justify their positions, right? And you can see the trays they've made, and then they have to do reflective learning at the end of it. Now, one of the interesting pieces is I give them candies as potential aggregates as well. That becomes pretty funny to everybody. And of course, we don't eat those in the lab, but it starts to make connections with them. And they can use Sour Patch Kids for pervious concrete to make big aggregates or something. So you can see there's different, this was probably a crack fill, and this was probably a pervious example of things that they came up with. And I guess I just want to point out, like, this is an example of how it can affect students. One is I've never seen so many smiles in my life during lab, and second, it turns out that we've flipped all of a sudden the traditional gender roles in engineering for who is the most comfortable, right? The guys, not always, but often, are less comfortable and have less background with this topic than the girls do. And as a result, a dynamic change happens in their relationships. The girls are usually in control. The guys look to the girl for answers in some ways. And it's just a different vibe that begins to happen. If you've got, that you need to watch the interdynamics of, but it becomes an empowering thing sometimes for some of the women. Another thing that I do, well, I'm going to skip that one. Lisa and a few, I believe, gave some active learning examples, and I will skip the ones that, I'll skip the ones that she already covered, such as reflecting, pair, share, the minute paper at the end of class, muddiest points, that kind of thing. And right now I'm going to flip over and start sharing another screen with you. I'm almost done. Okay, I hope you can see my webcam now. You should see some cards. This is one of the easiest things you can do to develop students' deeper learning and also keep minimal time for yourself, is to encourage reflection on what they've learned and connecting it to their background, okay? And so there are lots of ways we can do this. This is just one example that I want to show. First of all, it's been really interesting to me that while we've been on the pandemic and I've been teaching remotely, that the students prefer me to use a webcam. They actually, rather than any kind of online collaborative platform like Miro, which we've done, but they like this because it feels authentic, okay? If I stood in a classroom and I was able to put down paper and I actually write on here like I would if I was in a classroom on the blackboard, on the whiteboard. Anyway, this is a collection of different cards, and these cards are just a teaching resource, okay? And they're developed to help create easy ways to start moving into reflection as a habit, both in our personal lives, professional lives, but then also students as thinkers. Here's an example of one. They did a lot of analogies, and seemingly it may or may not be exactly what you need for your class, but this is an example of one where it talks about a bacterium, you know, having negative or positive feedback and moving towards an environment that's positive for it or negative. And they call that the rough and tumble. So you could take this and give it to them, changing it to say, apply to, okay, so far in this class, you know, what has been the run piece of this class for you, for your understanding, and which parts have been the tumble where it's been harder or you're not really sure or you want to back away from it. And then they give lots of questions back here. They weren't developed for any specific profession, and so you'll need to adapt it. What I like about these and giving people reflection is that there's really no right answers. That's a really nice piece of this, so you can't mess it up. Here's the second one.
Heather, about 1 more minute.
Okay, so favorite paradigm shift, this was an example of one. They focus on creating different mindsets and using different learning theories to finish. You can even encourage them to think about how their study habits are going and affecting their life. So with that, I'm going to finish up and be done. This is hard. It's hard, and you'll get pushback if you try to implement, right? But it's worth it. So thank you very much.